Okay, we want to do a quick training video on spin welds. First, we'd like to just show a couple spin welds here. Spin welds are primarily, we use them specifically to do one of two things. One would be to cover up a feature in a mold, like the vent hole, so we would use a patch. Secondly, these are patches in front of us. Secondly, you would use a spin weld to add a feature, like a threaded hole or something similar. So spin welding is an injection molding process. They make spin welds in a small or a medium-sized injection molding machine, and they come out of the machine looking something like this, where they're still connected to the sprue and the gate. And then you simply twist or cut off the actual spin weld, which is what we use in rotomolding, and you throw away the unused portion, and you're left with a spin weld, one on each side, or however many the cavity holds. So patches come in a variety of sizes and colors. I've got a couple shown here that are just black and natural, from large to medium size, clear down to small ones. And every spin weld has really two things in common. The top of the spin weld has some features which allow you to install it, and we'll show that in a minute. And the bottom of the spin weld has a feature which allows you to center it in your part and get it positioned exactly where you want it to. So you've got the centering feature and you've got the driving feature. On a smaller spin weld, it doesn't look that much different. There's a driving feature on the top and a centering feature on the bottom. That's also true for spin welds that aren't patches. So this has a driving feature on the top and those four knobs. This specific spin weld will allow you to get an internal thread, and this spin weld will actually sit down into the part, so it'll be a flush mount on the top. This spin weld is opposite. It'll sit like this in the rotomolded part, so it will sit, it'll sit like this, so you get an external thread that sits above the part. Here's another spin weld which has no thread, so this would be for a slip fitting, and this will actually sit into the part like this as well. And also we've got a spin weld which has threads on both the outside and the inside. So this is a double-ended threaded spin weld, and it will sit like this into the part with this top section sticking out. So we've got flush spin welds that are flush to the outside, flush to the inside. We have a variety of color options. Only two are shown here, but those who make spin welds can make them really in any color. So what we want to do is show you the spin weld process, and we've got 4 spin welds, different spin welds. We're going to show the drilling process as well as the installation process, and we will underutilize the spin weld intentionally. We will do it as best we can, and then we will overutilize the spin weld and show you what each of those processes look like. So we'll start with this small patch. It first needs to have a pilot hole, the same size as that the pilot on the underside of the spin weld. Go ahead. So since we're going to do 3, he will pre-drill all 3 of them. Each spin weld has a driver for it, and so the spin weld itself will sit inside the driver, which will allow you to drive it. All spin welds are installed with high-speed routers. Go ahead. So this first spin weld was not installed correctly, and with very little force you would be able to pull that right out. This second spin weld was installed properly. There's no way you're going to be able to get that to come out of the part. And lastly, we'll do another spin weld too much. If you go too far, you will see that half of it will be it won't actually end up sitting flush on the part. So you've got to maintain equal pressure all the way around the spin weld process so you can get the spin weld to seat exactly the way you want it to. We'll move on to the next size. This next size is done with the correct hole saw. This will be another patch. Underside has a centering feature. The top side has a drive feature. And this will fit nicely inside of the hole saw that was just drilled. Again, we will under install the spin weld, and then we'll install it twice more, once perfectly, and then we'll try to over install one. It's important to always wear the appropriate personal protective equipment, safety glasses, especially earplugs if required. This particular spin weld is installed using a high-speed router. It's best not to have the kind with a soft start. You want one that starts as quickly as possible. Okay, this first one was installed without enough dwell time, so if I had a screwdriver I'd probably be able to pop this thing right off. But these last two were installed much better. The idea of the spin weld is a friction process where you're actually melting the spin weld and the part together. And because of that, when you're done doing the spin weld process, you want to hold the spin weld in place for an appropriate amount of time until the two melted components cool down enough so that it'll stay. Go ahead. This spin weld is a threaded spin weld, and it has threads on a double-ended thread like I showed you previously. So there's a thread on the outside, there's a thread on the inside, and the driver will actually sit over the entire spin weld and hold it in place, and the spin weld will sit inside the part. Notice the smoke from the friction process. Also notice the puddle created around the part of the two parts melting together. This first one was likely not installed correctly, and in the field this one would certainly fail after a couple uses. These two are installed much better. One more spin weld to show you. A bigger hole saw. So here we have 3 pre-drilled holes. We're going to use another router with another driver for an even bigger spin weld. This will be a spin weld that'll actually sit flush to the inside of the part and has some internal threads as well. The same driving features on the outside, same centering features on the inside. Same driver hooked to a high-speed router. So again, we started with developing the spin weld process, and we were able to easily remove this one. We would easily be able to remove those if we were trying to use them in the field. I'm not able to do it by hand. This line of spin welds is perfectly installed. The idea is to do it just long enough to generate the friction and to melt them together, but don't waste any unnecessary time going overboard. This line of spin welds have all probably been, we've probably gone overboard a little bit. However, they still work. So as a rule of thumb with spin welds, it's always best to over install them as opposed to under installing them. In the case of threads, you want to ensure there's no leakage of perhaps water in or out. But in the case of these patches, sometimes the idea is to just cover a vent hole or to make a product watertight.